Hello everyone, welcome to my channel. Welcome to Dawood Academy. In today's video, I will be going over how to calculate the rate of change. And just before we go over the two main ways to calculate rates of change, I wanted to go over three basic sort of sections. In the first section, I would like to cover what is the rate of change, so you and anyone watching this video has a good understanding of why we need to calculate the rate of change, how that plays an important role for many calculations, whether in engineering, in other industries, business, medical field, health, even for budgeting. Basically, we see rates of change almost everywhere in our lives, and every day of our lives as well. So that would lead me on to the next section, which would be why is it important? And we're going to go over some just brief examples of where we see the rates of change and why would that be important. And then the third section would be how to calculate the two main rates of change. So just before I continue with the video, I'd like to thank you for visiting my channel. And if you like these videos, I'll be posting more and more as I go. I've been tutoring for 10 years, so it's a lot of experience on my end. I'd like to share that with you on my YouTube channel. And if you'd like to subscribe, please go right ahead. Click on the link below, click the subscribe button, and as you probably know already, if you want to see my videos coming up and YouTube will notify you, please click on the bell notification icon. So, all right, so let's dive through to it now. Let's get right to it. So what is the rate of change? Now, we look at a rate of change, we're seeing basically one variable or one sort of component, how that changes with respect to another. Now, an easy example would be something that you see every day. Let's say if you're getting onto a bus or onto a car, the easiest example that you would see would be like speed or velocity. Now, that's a very simple example, but how does that like, what does that mean? When we say rates of change or something that's changing. So as you can see from the name, it's something that is changing with respect to another. So when we look at velocity, we're dealing with v, which is your velocity, equals your distance or displacement over time. So when we look at that calculation, basically what we're saying is we want to see how the distance is changing with respect to a variable. The variable in this case is time. So v equals d over t. When you calculate velocity or calculate speed, you take the distance, total distance traveled over the total time, and then you get a somewhat, in this case velocity, it's a rate. So you're seeing how much your distance is changing with respect to time. Now, it doesn't always have to be with respect to time. You could be looking at measurements with respect to, for example, other parameters. So you could be looking in this case at, say, how much profit is a company making as the number of sales increases. So sometimes it's not a very linear relationship when we look at profitability of a company with respect to sales. So increasing the sales doesn't necessarily mean that, let's say if you have 10 times the number of sales, that's going to give you 10 times the amount of profit. Because when we look at these calculations, we see a lot of times that the variability changes not in a linear way, because there could be other reasons. When you have more sales, you need to expand your facilities, you need to do construction, for example, you need to open up or rent a larger facility, you need to hire more employees. There's also going to be the supply and demand effect. So when we're looking at rates of change, we're looking at one parameter one variable, in this case, we usually look at y with respect to another x. So the change in y over the change in x. And if you're probably have taken a previous math course before getting into rates of change, you know that the change in y with respect to the change in x, this is the slope. So when we're talking about rates of change, we look at one variable with how it's changing with respect to the other. It could be increasing as x increases, for example, or you could say, for example, the height of water in a swimming pool increases with respect to the total volume of the swimming pool. So as the total volume is increasing, also the height, let's say of water, total volume of water, and also the height of water is increasing. So that gets us a little bit of an idea of rate of change. Now, why is it important? So we touched base a little bit about profitability of a company, for example. So company wants to know that if they have X amount of sales, how is that going to affect their profitability? How's their profit and profitability changing over, say, a period of time, or as number of sales in, say, becomes doubled or tripled or 10 times or 100 times? So profitability is important for every company. Another issue, for example, or concept that we can look at, see rates of change, is how a medication is being given to a patient. So we see rates of change, for example, in dosage calculations, how much medication is being given to a patient over a period of time. So that amount of dosage, for example, could be in milligrams per minute. Okay, so let's say milligrams of aspirin per minute. So that's something we look at in, say, the medical industry or medical field, health. You can also look at concepts of rates of change where it would be important is we look at sports. If we look at sports, say basketball, if we look at, let's say, soccer, any of these sports, you see a lot of times where rates of change play an important role. For example, how many 3 points can a certain basketball player, let's say Steph Curry, how many 3-pointers can he make in 20 minutes? You know, so when we look at our calculations in basketball of streaky players, you know, when we look at players that are so-called on fire, they'll be, for example, in 10 minutes they could score 25 points or 30 points, whereas we can calculate that as an average over a whole game or over a certain number of minutes, and we can compare that with other players. So we look at rates of change is important because we can compare between, say, player A and player B, how much better is player A, say, in the 3-point shooting 3-pointers compared to player B. Or if we look at two companies growing, one company, it could be growing at a much faster rate than another company, or how much a product is in demand. Initially could be starting off with a high demand, so a high rate of change, high acceptance rate in society. And over time, it may start to drop or may start to level out. So we look at rates of change and comparing between parameters, comparing between two of the same kind or two of the similar industries. If we look at how much material passes through, say, an extruder over a period of time, we look at that as a flow rate, the mass flow rate. So why is it important? It's because we see it every day, and we use that in charts and graphs to compare parameters, to compare different aspects, different technologies, what is enhanced, what is not, what's better, what's not. So it's used in a lot of concepts and industries, manufacturing. It plays a vital role. So now we can move on to the third section, is how do we calculate the rate of change? We talked about rate of change. We have an idea of now it's one parameter with respect to the other, and it's related to the slope, okay, that you can calculate this rate of change from the slope of an equation. Now, what does that exactly mean? How do we calculate it? So we're going to talk about two concepts here. The first one is the slope of the secant. And what the slope of the secant is, it's basically the rate of change across 2 points on a graph. What does that mean? So let's just draw a quick near graph. I'm just going to draw any sort of shape representing a function. So let's say this is your function. And let's say this is considered, say, day 1. And this is considered day 3. These are days. And then here, let's say this represents on our y-axis. This is x. This is our y. And on our y, we're representing it by, let's say, temperature in degrees Celsius. So when we look at the slope of a secant line, the slope of a secant line gives us the rate of change over an interval. Now, that's important, right? You want to know, okay, between day 1 and 3, what is the change in temperature? That's basically what this tells us. If we draw a line, let's get a line here, between days 1 and 3, and if we find the slope of that line, we're going to be able to get the rate of change along that interval. And if you remember the rate of change, it's the rise over the run. So rise over the run. And this gives us the rate of change on an interval, so we call it the average rate of change, or ARC. So that's the average rate of change. I'll just write that here. All right. Average rate of change. Okay. So basically, if we look at ARC, or average rate of change, all you really need to know is the coordinates of 2 points and find the slope of the secant, which is slope of that line. So you just connect the 2 points with the line. If you know their coordinates, then you can follow the formula of the rise over the run, or your delta y over delta x. So let's say at day 1, the temperature was 25 degrees. So I'll just go back to writing this out. So let's say at day 1, you have 25. So the coordinate would be 1, 25. And let's say day 3, series this. So let's say at day 3, the temperature dropped to say about 10 degrees. So you have the coordinates of these 2 points. To find the slope of the secant, which would give you the average rate of change, you just write here MSEC, or slope of the secant. That's an abbreviation. And you can follow the formula. The rise over the run is the change in y, the change in the y coordinate. So y2 minus y1 over the change in the x coordinate. So x2 minus x1. So the far right minus the far left. And we do the quick calculation here. So the y coordinate of the second point, or the farthest to the right, you can use either or, but usually you follow a left-handed method from left to right. It's going to be 10 minus 25 over x2 minus x1 is 3 minus 1. So that gives you 10 minus 25 is negative 15 over 2. Goes negative 7.5. And you look at the units based on, so we look at the units based on what is in the numerator over what is in the denominator. So in the numerator we have our y-coordinates, which represent temperature, degrees Celsius. And in the denominator, it's our x-coordinate, which represents days. So we can see that on an average between day 1 and day 3, the average rate of change is negative 7.5 degrees Celsius, degrees C, over or per day. So over that period of time from day 1 to day 3, the rate of change, how the temperature is dropping, is by 7.5 degrees Celsius per day. And that's the average rate of change over that interval. Now that's very important, but what's equally important and probably used more is we want to know how is the temperature, for example, or how is something changing at that particular instant, or how is something changing as the other variables changing at the same time, not necessarily on an interval. So here we calculate an average between 1 and 3, but what if we wanted to know what's the rate of change at day 1? Okay, so to find the rate of change, for example, at day 1, we need to go into something a little bit more in depth, and that's something called the instantaneous rate of change.